Good morning, all of you. Today we are going to see unit number 2 is orthographic projection. Orthographic projection is nothing but the representation of three-dimensional view in two-dimensional view. That means three-dimensional view of an object will be given, and from that we have to draw two-dimensional view. That means if we are looking from the front direction, then we have to draw the front view. Then if we are looking from the top direction, then we have to draw the top view, and if we are looking from the side direction or side view, then we have to draw either left hand side view or the right hand side view. Before seeing how to draw the two-dimensional views from three-dimensional view, we'll see the projection theory. Now projection is nothing but the image or shadow of an object which will fall on the ground or any wall. Now here we will see that a man is standing in front of the wall and the light is on through the torch. So as soon as the light is on, the light rays are passing through the torch. It will touch the outer periphery of the man and then it will fall on the wall and we'll get the image. So that image is nothing but the projection. So in engine graphics, that image we can call it as a projection. Now other terms are also designated as this wall, we can call it as a planar projection. Then the man which is standing in front of the wall and the torch, that man is nothing but the object and the torch is nothing but the observer. So uh, and the light rays which are coming through the torch, that light rays are nothing but the projector lines. So in engine graphics, the wall is nothing but the plane of projection, that image is nothing but the image or the shadow is nothing but the projection, the man is nothing but the object and the torch is nothing but the observer, and the light rays are the projector lines. And the condition to get the projection is that the object should be in between the plane of projection and the observer. That means the object should be in between the man, it should be in between the wall and the torch. Now again we'll see here one block is kept in front of the screen and the light source is on. That light source is nothing but the observer. So as the light source is on, the light rays are passing through it, through the object's outer, it will touch the outer periphery of the object and will get the image on the screen. So that image is nothing but the projection and the light rays are nothing but the projectors. Now if you see in this case, the light rays are coming at certain angle, so we are getting some enlarged view or enlarged image on the screen. But in case of orthographic projection, we assume that the light rays are coming parallel to the object and perpendicular to the plane of projection. So whatever is the size of the object, so the same size we are getting it on the plane of projection. So this is nothing but the theory of projection. Now to get the projection on the planes, we have basically three principal planes. First one is the horizontal plane, second one is the vertical plane, and third one is the profile plane. If the observer is looking from the top direction, then we will take its projection on the horizontal plane. That projection we called it as a top view. If the observer is looking from the front direction and we are taking it projection on the vertical plane, that projection we called it as a front view. And if the observer is looking from the side direction and we are taking its projections on the profile plane, then we can call it as a left hand side view or the right hand side view. If we are looking from the left direction and we are taking it projection on the side profile profile plane, then we can call it as a left hand side view. Similarly, if we are looking from the right side and we are taking it projection on the profile plane, then we can call it as a right hand side view. Now here we'll say see one example. The object is kept in between front vertical plane and the horizontal plane. Now the observer is looking from the right side, and we are taking it projection on the vertical plane, and the condition is satisfied, that is the object is in between the vertical plane and the observer. So the projections the projection lines are coming parallel to the object and perpendicular to the plane of projection, that is vertical plane, and we are taking it projection on the vertical plane. That projection we can call it as a front view. Now the observer position will change. Now the observer will look from the top side or top direction, and the projection lines are taken parallel to the object and perpendicular to the horizontal plane, and we are getting the projection on the horizontal plane. So that projection we can call it as a top view. So whatever the actual size of the object, same size we are getting it on the vertical plane and on the horizontal plane. So that projection we can call it as a front view on vertical plane, and the projection on the top horizontal plane we can call it as a top view. Now we know that when the two principal planes are cutting each other, then it will forms a four quadrant, that is first quadrant, second quadrant, third quadrant, and the fourth quadrant. The object can be placed either in a first quadrant, second quadrant, third quadrant, and fourth quadrant. If the object is placed in a first quadrant, then we can call it as a, and we are taking the projection, then we can call it as a first angle projection method. If the object is placed in the second quadrant, then we can call it as a second angle projection method. Similarly, if the object is placed in a third quadrant, then we can call it as a third angle projection method. And if the object is placed in the fourth quadrant, then we can call it as a fourth angle projection method. Out of these four methods, we generally keep the object either in a first quadrant or in the third quadrant. We never keep the object in the second quadrant and the fourth quadrant. Now see, if the object is placed in the first quadrant, and the observer will for taking the projection on the vertical plane, if the observer will look from the right side, and we will get the projection on the vertical plane. That is front view. To take the projection on the horizontal plane, the observer position will change, and the observer will look from the top side and will take the projection on the horizontal plane. That means we'll get the top view. Now to convert this three-dimensional view into two-dimensional view, what we will do, we are keeping the vertical plane constant, and we are rotating the horizontal plane in a clockwise direction by 90 degree. So as soon as we rotate this horizontal plane in a clockwise direction by 90 degree, what will happen, the front view will be above XY line and the top view will come below XY line. Okay. So in case of first angle projection method, we will get front view above XY line and top view below XY line. Now if we are keeping the object in the second quadrant, then what will happen, we are getting the front view on the vertical plane, we are getting the top view on the horizontal plane, but as per our convention, we are keeping the vertical plane constant and we are rotating the horizontal plane in a clockwise direction by 90 degree. Then what will happen, this projection on the vertical plane and the projection on the horizontal plane both are getting overlap, so we cannot able to see the as both the views are getting overlap, it is very difficult to understand the drawing. So because of that, we never keep the object in the second quadrant. Now assume that the object is placed in the third quadrant. Now the object is kept in the third quadrant, now the observer will look from the left side, the object is in between the vertical plane, and the observer will get the projection on the vertical plane. Then now the observer position will change. Now the observer look from the bottom side and we are getting the projection on the horizontal plane as a top view. So one projection we have on the vertical plane, another projection we have on the horizontal plane. Now as per our convention, we are keeping vertical plane constant and we are rotating the horizontal plane in a clockwise direction by 90 degree. So what will happen, the top view will go above xy line and the front view will remains below xy line. So in case of third angle projection method, the top view will be above, always above xy line, and the front view will be below xy line. Now next we'll assume that the observer is object is placed in the fourth quadrant. Now when the object is placed in the fourth quadrant, first we'll take the projection on the vertical plane. For that, observer will look from the right side. We'll take the projection on the vertical plane. Then we'll take the for taking the projection on the horizontal plane, observer position will change. Observer look from the bottom side. We are getting the projection on the horizontal plane. Okay. Now as per our convention, we are keeping vertical plane constant and we are rotating the horizontal plane in a clockwise direction by 90 degree. Then what will happen, both projection on the vertical plane and the projection on the horizontal plane are getting overlap, and it will be very difficult to understand the drawing. So because of that, we never keep the object in the second quadrant and the fourth quadrant. So we generally keep the object either in a first quadrant and in the third quadrant. So if we are keeping the object in the first quadrant, the front view will be always lying above the xy line and the top view will be lying always below the xy line. Whereas if the object is kept in the third quadrant, in that case the top view will be always above xy line and the front view will lie always below the xy line. So that is the difference between the first angle projection method and the third angle projection method. In our syllabus, we are only following the first angle projection method. So whatever the object or whatever the exercise we are going to do in orthographic projection, that we are going to do with the keeping the object is in the first quadrant only. Now we will see representation of the object if it is placed in the first quadrant. Now one block is given, it is placed in the first quadrant and we have to draw its front view, top view and side view. Now for taking the projection on the vertical plane, the observer will be looking from the right side. Okay, so as the observer is looking from the right side, we'll take it projection on the vertical plane and we'll get the projection as a on vertical plane. Okay, next the observer position will be changed. Now the observer will look from the top side or top direction and will take it projection on the horizontal plane and will get the projection as a B on the horizontal plane, right? Now next we will take the projection on the profile plane. Now if we are looking from the right side, for the front view, the side which is open is left hand side, that is the left hand side of the object. So we are taking the left hand side view on the profile plane. So as we are looking from the left side, we'll get the projection on the profile plane as a C. That means we'll get projection as a C on the profile plane. Now we have to convert it into the two-dimensional view. So as per our convention, first we will keep the vertical plane constant and we will rotate the horizontal plane in a clockwise direction by 90 degree. As we are rotating the horizontal plane in a clockwise direction by 90 degree, we'll get front view above xy line and top view below xy line. So front view will be above xy line and the top view will be below xy line. Then again we will keep vertical plane constant and we will rotate profile plane in an anti-clockwise direction by 90 degree. So as we are rotating the profile plane in an anti-clockwise direction by 90 degree, that left hand side view will come on the right hand side of the front view. So if the object is placed in the first quadrant, the left hand side view will come always on the right hand side of the front view. So its orthographic projection will be like this: front view, below front view will have a top view, and on the left hand side of the front view will have a on the right hand side of the front view will have a left hand side view. Okay. So system of orthographic projection, as we as I have told you earlier, that whatever the projections we are taking on the vertical plane, that projection we called it as a front view or elevation. Similarly, whatever the projections we are taking on horizontal plane, that projection we called it as a top view or plan. Similarly, the projection, whatever the projections we are taking on the profile plane, that projections we can call it as a left hand side view or right hand side view. If we are looking from the left side and we are taking it projection on the profile plane, that projection is nothing, is left hand side view. And if we are looking from the right side and we are taking it projection on the profile plane, that projection is a right hand side view. Now we'll take one example and we'll see how the representation of first angle projection method once again. Now one block is given, and the observer is looking from x direction. X direction is always shows the front view direction. So if you are looking from x direction, this rectangular rectangle will be as a projection for the front view. Now next, the observer position will be changed. Now the observer is looking from the top direction and will get the square as a projection in the top view. Next is, if we are standing in x direction, the side open of the object is left side. Okay, that is y direction is here is given, and y direction always shows you the side view direction, and that is left hand side view in this case. So for this, orthographic projection will be like this. First we'll draw the xy line, x1 y1 line, and earlier we have seen that in this case the side view is the left hand side view, and the left hand side view will be always lying on the right side of the front view. So first we'll draw front view. Below front view we'll have top view, right? And for drawing the left hand side view, first what we'll do, we'll first from the origin or intersection of the xy line and x1 y1 line, we'll draw a line inclined at 45 degree. Then we'll take it projection from the top view on this 45 degree inclined line. Then from the point of intersection of 45 degree inclined line and the projection from the top view, we'll take the projections vertically upward. Okay, then we'll take the projection parallel to the xy line from front view. Then we'll get the block for side view. That side view is nothing but the left hand side view. Okay, so this is the representation for orthographic projection for this block. So if we are drawing, for the same case, if we are taking the projection from the right side, the representation will be like this. Front view, below front view will have a top view, and on the right hand side of the front view will have a left hand side view, and similarly on the left side of the front view will have a right hand side view. So for the first angle projection method, we have to keep in mind that we have above xy line front view, below xy line top view, and on the right hand side of the front view we'll have a left hand side view, and on the left hand side of the front view we'll have a right hand side view. So this is the representation of first angle projection method. Now consider one frustum of a cone. So we'll see symbol for first angle projection method. We have a frustum of a cone and we are looking from the right side. So this is the symbol. If we are looking from the right side and we are taking the front view, we'll get the first trapezium as a projection, and the left hand side view will be the two circles. One is a smaller diameter circle and another is a larger diameter circle. So this is the symbol for first angle projection method. Now we'll see some examples before actual drawing the objects. We will see some examples. Now this is the object. This is the front view direction is given. So if we are looking from the front view direction, okay, the object which is in a pink color, that will be directly visible for the front view. So the front view projection will be like this. This is the front view. Now the observer is looking from the top direction and we are taking the projection on the horizontal plane. So when the observer is looking from the top direction, the object is which is in the green color, that will be visible when the observer is looking from the top direction, and will get the projection. The top view is like this. Okay, now in this case we have to draw the left hand side view, because if we are standing or if we are looking from front view direction, the side open, it will be the left hand side view of the object. That means we have to draw the left hand side view. So when the observer is looking from side view, the ob- object which is in the blue color will be visible. So we'll get the projection for the side view will be as this, and that side view is nothing but the left hand side view. So in this case, its orthographic representation will be like this: xy line, x1, y1 line. Now as it is a left hand side view, that we have to draw it on the right side of the front view. So here we'll draw the front view. Below front view we'll have top view, and on the right side we'll have a left hand side view. Now in this case they have not shown the 45-degree inclined line, but in actual when we are going to draw the object, we will draw a 45-degree inclined line from the intersection of xy line and the x1 y1 line, and then we'll construct the left hand side view. Okay, now we'll see another problem. Here we have another example, and we are looking from the front view. We will first draw the front view. This is the front view direction. So if we are looking from the front view direction, the object which is in the pink color will be visible. Now in this case, one hidden line will be also there, because on that part there are two hidden lines that are not visible. So that portion we have shown it by the hidden lines. Now the observer position will be changed. Now the observer is looking from the top direction. So the object which is in a green color, that will be visible when the observer is looking from the top direction. Again in this case also we have at the bottommost lines or bottommost two corners we are not able to see from the top view direction, so that we have to show it by the hidden lines. In case of orthographic projections, whenever we are drawing the front view or top view or the side view, we have to see the hidden corners. If that corner we are not able to see directly, so that corner, the line passing through that corners, that we have to show it by the hidden lines. So this is the top view. Now again this is for left hand side view. So the portion which is in a blue color, that we have to show it by the left, for the left hand side view. So this is the projection for the left hand side view. Now next is the orthographic projection. For drawing the orthographic projection, again we'll draw the xy line, x1 y1 line. Now in this case again we have to draw the left hand side view. So left hand side view we are drawing it on the right hand side of the front view. So on the left side we'll draw the front view. Below front view we'll have a top view. And on the right side of the front view we'll have a left hand side view. So this is the orthographic projection for this three-dimensional object. Now we'll see the precedence of the lines. We have seen in very first lecture that we have different types of line. First line is object line. Okay, then second line is projection line, then we have axis of symmetry line, then we have center lines, then we have hidden lines. So when the different types of lines are overlapping, then which line we have to show, that will be, we will see here. The first rule is what? When First rule is, when hidden lines or dotted line coincides with the object line will take precedence over the dotted line. That means whenever the hidden line and the object lines are overlapping with each other, then we have to show only the object lines. That means a dark line. Second rule, when the center line coincides with the dotted line will take the precedence over the center line. That means when the center line is coincides with the hidden line, then we have to show the hidden lines only. And third one is, when the center line coincides with the cutting plane line, then cutting plane line will take the precedence over the center line. So these are the rules for precedence of the lines. Then hidden edges of an object are drawn. This is fillets and rounds. Whenever we have to draw the fillets and rounds in orthographic projections, that will be shown like this. Here we have shown the fillets and rounds in orthographic projections. So whenever any part is joined tangentially, so that part either in a front view or in a side view, we have to show it by runouts that we have, that is shown over here. Then this is also, I have told you earlier, the x directions shows you the front view direction, y direction shows you the side view direction. Again, we'll see some examples again for practice. Here is the object is given, x direction is shown, y direction is shown, and we have to draw its two-dimensional view. So as we are looking from x direction, for that is the front view direction, so the side open of the object is the right side, that is we for the side view we have to draw the right hand side view. So its orthographic projection will be, as we have to draw the right hand side view, that we have to draw on the left hand side of the front view. So its orthographic projection will be like this. Front view, below front view will have a top view, then we'll draw a 45-degree inclined line, and on the left side of the front view will have a right hand side view. Then again another example, again in this case also x direction, we are looking from x direction for the front view. The side open is right side, that means we have to draw the right hand side view. Its orthographic projection will be same. In the front you will get triangle as a projection, in the top you will get the rectangle as a projection, and on the right hand side you will get a rectangle as a projection. Now while drawing right hand side view, now in this case here for right hand side view we have a slant part, right? That is slant edge is there, but whenever that slant edge will take the projection on profile plane, we'll get the straight line only. So we'll these two slant lines we have to show it by the straight lines only. So we'll get the rectangle as a projection in the right hand side. Now here another example. Now in this case, if you are looking from x direction for front view, the side open will be the left side of the object, that means we have to draw the left hand side view. Now for the front view we'll get the projection like this for the top view. Then here we have to draw the left hand side view, so left hand side view we have to draw it on the right hand side of the front view. Now while drawing the left hand side view, there is one edge that will not be visible, so that edge we have to show it by the hidden lines. Another example here, again we are looking from x direction, and the side open of When object is left side, that means we have to draw the left hand side view. So we'll get the front view, top view, and on the right hand side of the front view we have to draw the left hand side view. Now while drawing the left hand side view, again in this case curvature part is there. So from the outermost part of the curvature, or innermost part of the curvature, that line we have to show it by the hidden line, as it is shown over here in the left hand side view, because that will be edge. That edge we are not able to see directly when we are looking from for the side view. So that edge we have to show it by the left hand side. So before, this is the basic for orthographic projections. So we'll stop for today here. For better understanding, you can refer the book of Tata Memorial publication Andy Bhatt. And in next lecture, we are going to see numericals on this orthographic projections. Thank you.